Okay.
And it looks like pretty much everybody's here. So um, let's all welcome Alan Robock. He's a distinguished professor at Rutgers University in New Jersey, which means that he has gained a considerable international reputation. He received his Bachelor of Arts from this university, University of Wisconsin-Madison, in 1970. And maybe you remember the name Lyle Horn. That was his advisor. And then he went to MIT and got his PhD and master's. That was 74 and 77, working with Ed Lorenz. Of course, who knows who that is, but Ed Lorenz, somebody. No, so that's
And Norm,
pretty amazing
and
to
Norm
get a chance
Phillips
to work with him.
Norm Phillips was my master's advisor.
Oh, okay. Wow. So you know how to do coding, probably. Numerical modeling.
My first class I ever took in meteorology was from John Kutzbach, who sadly died recently.
Well, Alan's expertise, he has many, but the three primary ones are nuclear winter, geoengineering, and volcanic eruptions and climate. He is a fellow of the AMS and of the AGU, and also the American Association for the Advancement of Science. He was also part of the team that got a Nobel Prize for the IPCC report. He won the Jewel Charney Medal in 2015 for his expertise in stratospheric aerosol. He has more than 260 peer-reviewed papers. And today his talk will be climatic and humanitarian impacts on nuclear war.
So thanks very much for inviting me. Can you see my screen?
Yes.
So yeah, I took Lyle Horn's integrated liberal studies class, and the meteorology department was in Science Hall then. I remember when I was a sophomore, we moved to the new building, which is which is now more than 50 years old. So it makes me feel old. But so I'm going to talk about the climatic and humanitarian impacts of nuclear war, because Rutgers is older than the United States. We celebrate our 250th anniversary 5 years ago. I want to acknowledge that the namesake of Rutgers, Colonel Henry Rutgers, owned slaves, as did many of the early presidents of Rutgers College, and slave labor built our campus, and the land on which the campus sits was stolen from the Lenni Lenape natives. And Rutgers likes to say we're a land-grant university, but what that means is that it allowed New Jersey to sell land that was taken from Western Native Americans for the benefit of Rutgers. We've had a project to look at that recently at Rutgers history, but we're trying to work beyond that. This is the obituary for Sherry Rowland, who won the Nobel Prize in Chemistry in 1995 with Mario Molina and Paul Crutzen. This is in EOS. He said, "What's the use of having developed a science well enough to make predictions if in the end all we're willing to do is stand around and wait for them to come true?" And he asked at the White House, is it enough for a scientist simply to publish a paper? Isn't it a responsibility of scientists, if you believe you found something that can affect the environment, isn't it your responsibility to actually do something about it, enough so that action actually takes place? If not us, who? If not now, when? So this idea is what motivates me to work on this topic. So I'm going to talk about the nuclear winter theory, and then, because we can't test it, we look at analogs in the climate system, and then about policy implications, and then doing something about it. And I've recently joined the Physicists Coalition for Nuclear Threat Reduction, which also accepts meteorologists, so I'll talk about that at the end. And by the way, I've heard this talk before, so if anybody has any questions, just stop me and ask as I go along. This is our beautiful planet, but after a nuclear war, it might look like this, with clouds of smoke covering the northern hemisphere, being blown into the southern hemisphere and blocking out the sun. And if there's enough smoke, it would make it so cold in the summertime that temperatures would be below freezing, and we call that nuclear winter. It would also be dry, there'd be less precipitation because the hydrological cycle would be weaker, there'd be less sunlight, more ultraviolet radiation because of destruction of ozone, and this would produce a global famine. If there's enough smoke, there wouldn't be any food for anybody. That's what nuclear winter is. Here's a history of the number of deployed nuclear warheads. And you can see there, can somebody tell me how many countries have nuclear weapons? Can you hear me?
Maybe 6.
6. Another guess?
7 or 8?
9.
I'm pretty sure it's 9.
Wow, you're very
15?
educated. 15? Okay, well, the answer is 9, and actually the consensus forecast was the best, because if you average all those guesses, you get to about 9. The US and Russia have more than 90% of all the weapons, and so I've plotted the total number and the US and Russia separately. And you can see that, can you see my mouse as I move it around on here? No?
Yes, we can.
Yeah, we can see that.
So the total was up to 65,000, and it's been going down. So why did the nuclear arms race end? Well, in 1982, Paul Crutzen, who shared the Nobel Prize with Sherry Rowland, who tragically died about a week ago, and John Birx wrote a paper saying there'd be smoke from nuclear war, and the smoke might cause climate change. And then in the next year, a Russian group, Alexandrov and Stenchikov, and an American group, Turco, Toon, Ackerman, Pollock, and Sagan, wrote papers. The Turco group, called TAPS, created the name nuclear winter. And they both agreed that there would be climatic change after nuclear war. And then the next year, the group at NCAR, Kurt Covey et al., and I wrote a paper separately in Nature about the climatic effects. And then the nuclear arms race ended, and the Cold War ended. And I assert that this was cause and effect, that this was telling truth to power, and that there was that was part of the reason why the nuclear arms race ended. Another idea is that it was because the Soviet Union collapsed, but the Soviet Union didn't end until 5 years later. And by the way, the number now is not 0. So the problem has not been solved. We still have lots of nuclear weapons on the planet. Now, why do I claim this is true? When we do science in meteorology and climate, we run models, we look at data, we have testable hypotheses, but historians just ask the people that made the decisions. So the decision to end the arms race was from Ronald Reagan, US president, and Mikhail Gorbachev, who was running the Soviet Union. And Reagan, in a New York Times interview, said, "A great many reputable scientists," he called me reputable, "are telling us that such a war would just end up with no victory for anyone because we'd wipe out the earth as we know it. If you think back to natural calamities back in the last century, 1800s volcanoes, we saw the weather so changed there was snow in July in many temperate countries. And they call it the year in which there was no summer. Now, if one volcano can do that, what are we talking about with the whole nuclear exchange, the nuclear winter that scientists are talking about?" And Gorbachev said, "Models made by Russian and American scientists showed that a nuclear war would result in a nuclear winter that would be extremely destructive to all life on Earth. The knowledge was a great stimulus to us."
Hey, Ellen, I don't know if you saw, but there was a question in the chat. Jack asked, where did weapons go that have, you showed the decrease in nuclear weapons.
What happens to them? I didn't see the chat, so I don't know how to use chat in this. Is that where that little circle with a number with a 6 by it?
No, that's,
anyway.
I'll let you know if I see anything come up.
Okay. The answer is you take them apart. And they use plutonium and highly enriched uranium, and you can dilute them, make them so they can't be used for nuclear weapons anymore. When the Soviet Union ended, the Nunn-Lugar Act, this was two senators, a Republican, a Democrat and a Republican, spent money to hire Russian nuclear scientists to take them apart so that they would have a job, they wouldn't be tempted to sell them to terrorists. And a lot of the material was sent to the United States, diluted and used as fuel for nuclear power reactors. So you just take them apart, and we can put them together, we can take them apart. It's easy to do. Does that answer the question? So that was 40 years ago. So why am I talking about it now? So I want to ask two questions. Although the Cold War is over, could the remaining nuclear arsenals still produce nuclear winter? And as I mentioned, there's 7 other countries with nuclear weapons, including countries like India and Pakistan. What would happen if they had a nuclear war? So the answer is, in case you want to go on to something else, is yes, we can still have nuclear winter from the remaining arsenals, and it would last for many years. And a war using much smaller number of nuclear weapons in the US and Russia wouldn't bring temperatures below freezing, but it'd still be a terrible catastrophe from the direct effects, blast, radioactivity, and fires. And there would still be severe impacts on global agriculture for a decade. So I'll show you that. What happens with a nuclear weapon? We used to test them in the atmosphere. Here's a picture from the Nevada Proving Ground. You can see the dignitaries there with their fingers in their ears and sunglasses on, and they blew up a nuclear weapon. And it's like bringing a piece of the sun to the earth for a fraction of a second, and everything within a certain distance just will burst into flames because of the flux of energy. And they built this house to see what would happen, and you can see it's lit up at night by the light from the blast. And as the fireball rises, the shadow gets shorter, but then it begins to burn. But then the blast wave hits like thunder following lightning and begins to blow it apart. And you say, well, maybe it's going to blow out the flames, but it's also going to break the gas mains, it's going to break the electrical lines, and you can imagine the fires would continue to burn. If the material that burns has a lot of oil in it and a lot of plastic, then it produces this black sooty smoke, and that's what would cause the most climate change. It would be heated by the sun and go up into the atmosphere. Now, this is a history I learned not too long ago that most people, it's not in our history classes. On March 10th, 1945, during World War II, the United States sent over 300 airplanes over Tokyo to basically burn the whole city down. 2 of them had napalm. They planted an X at night on the city, and then all these planes came in and burned it down. And then every few days for the whole summer, we burned cities in Japan. Curtis LeMay, the general, was in charge of this, and he said, we can't bomb in the daytime because our bomb sites aren't good enough and they can shoot us down. So we'll just go at night and use incendiary bombs. But general, won't that kill a lot of innocent civilians? Well, everyone probably has a drill press in their backyard working for the army, so that's okay. We'll kill everybody. And we killed over 800,000 people in Japan that summer. That day in Tokyo, more people burned to death in 24 hours than ever before in the beginning or in history or since then. So this policy of genocide was already part of U.S. policy. In August, 2 cities were burned each instead of having a whole fleet of airplanes, they just used 1 bomb each. One was Hiroshima and one was Nagasaki, and then the war ended. But it's not clear at all that the atomic bombs helped end the war. The war was about over anyway. So what happened? On August 6th, we dropped a 15 kiloton bomb, 15,000 tons of TNT explosive power, and it killed about 150,000 people. About half of that directly and others over time. 15 kilotons was about 1/millionth of the 1985 World Arsenal. It's about 3/millionths of the current World Arsenal in terms of explosive power, because our bombs are much bigger now. So if you dropped a Hiroshima bomb every two hours, every day for 75 years, since then, you still couldn't use up the current arsenal. This is the airplane, the Enola Gay. This is a picture of me back when I had hair and it was black at the Smithsonian. And this is a model of the little boy bomb, the uranium bomb that was dropped. This airplane's now on display out by Dulles Airport if you want to go see it. These are photographs taken. The one on the left is the mushroom cloud from the bomb, and the one on the right was taken 3 hours later. It's a pyrocumulonimbus smoke plume. So this bomb started to fire, and the air came in from all directions and pumped the smoke high up into the atmosphere. This is a drawing of one of the survivors. What they remember is the fires. And this is what Hiroshima looked like afterwards. All the buildings were burned. 3 days later, we dropped one which was a plutonium bomb. It was a spherical implosion. It was called Fat Man. So here's a picture from the Nagasaki Museum of Fat Man and the bomb. And this is what the mushroom cloud from Nagasaki. It's about a 20 kiloton bomb. And this is what Nagasaki looked like afterwards. Now, cities can burn without nuclear bombs or without incendiary bombs. In 1906 in San Francisco, there was an earthquake that shook the city. And Jack London, the famous author, was asked to write about it, and he wrote in Collier's, which was a very popular magazine at the time. So within an hour after the earthquake shock, the smoke of San Francisco's burning was a lurid tower visible 100 miles away. And for 3 days and nights, this lurid tower swayed in the sky, reddening the sun, darkening the day, and filling the land with smoke. I watched the vast conflagration from out on the bay. It was dead calm, not a flicker of wind stirred. Yet from every side, wind was pouring in upon the doomed city. East, west, north, and south, strong winds were blowing upon the doomed city. The heated air rising made an enormous suck. Thus did the fire of itself build its own colossal chimney through the atmosphere. So it's a classic pyrocumulonimbus. This is what San Francisco looked like afterwards. A photo taken from some kites on a. So we know that cities can burn. In 1982, the Swedish journal Ambio had a special issue, and they asked people to write about what the consequences would be. And Paul Crutzen, who's an atmospheric chemist, and John Birx wrote a paper on how it would affect tropospheric ozone. And tropospheric ozone, as you know, is a photochemical reaction that requires sunlight. And they pointed out that there would be fires, and the fires would produce smoke, and that would affect the generation of ozone near the surface. And by the way, the smoke could cause climate change.
Alan, there was another question from.
Sure.
He said, so the bombs create a large local low pressure minimum?
Well, it's a fire. It's a fire. So the air would rise, and then yes, and then wind would come in from all the different sides. So it's a very local phenomenon. We, as I'll mention later, we see that after big forest fires too. So this team of Turco, Toon, Ackerman, and Pollock and Sagan. In 1982, I went to the AGU fall meeting, and there was a there was a talk on the climatic effects of nuclear war. And I went to it, it was canceled. It turns out that these Tom and Brian and Rich worked for NASA, and NASA said, you can't talk about nuclear war and you have to cancel it. We'll lose our funding. And so they went back and thought about it. What should we call this? And they said, well, let's put the forcing and response in 2 words. They called it nuclear winter. And they published a paper in Science the next year. And this is called the TAPS paper, from the acronym from their last names. And they use a single column radiative convective model. So the whole world was in one column with a land surface, and they calculate over 300 days for many different scenarios what would be the climate response. And this is a graph of the surface temperature response. For the 5,000 megaton baseline case, that was about a third of the current arsenal at the time. And temperatures would rapidly go below freezing and last for a couple months. Now we know the smoke would be heated and lofted in the upper atmosphere, and it would last for years, but at the time they didn't know how long the smoke would last. And they calculated, because it's a 1D model, they could calculate temperature change in the vertical. There'd be a huge amount of heating in the stratosphere, and this would destroy ozone. At the surface, you'd get cooling. Alexandrov and Stenchikov heard about this from the Americans, and they did a GCM model, and they used the Mintz-Arakawa GCM run on a Besem 6 Russian clone of an IBM computer with a 12 by 15 degree latitude longitude grid. That's kind of low resolution by today's standards. And they ran it for 400 days. They did one ensemble member. They said it took 40 hours of computer time to do 1 year simulation. And Gero Stenchikov, who came to work with me later, said we didn't have enough memory on the computer, so we would do the northern hemisphere, we would read all the output out to a tape, and then read it back in again and do the southern hemisphere and go back and forth. So, but this is what they got. This is the cross section of the vertical circulation. They got an upward ITCZ in the control run, but then the smoke would heat the air and have this huge circulation blowing it into the southern hemisphere. And this is the surface temperature on day 40, surface temperature change. And under the smoke, you would get these huge coolings, and temperatures definitely get below freezing. So even with a very low resolution model, the basic physics are that if you block out the sun, it gets cold at the surface, and that's what they got. And then I took an energy balance climate model and did calculation of for 4 years, and I put in the smoke, and this is the graphics I had. It was a pen drawing in. This is the surface temperature change over land, and for the first 3 years from the North Pole to the South Pole. And what I found is that even if the smoke was gone, I assumed it would be gone by then, you would have a snow albedo feedback would enhance the cooling for a couple years, so the effect wouldn't go away even after a year. And then Starley Thompson at NCAR, working with Steve Schneider, used NCAR GCM, but they on the Cray supercomputer, which is orders of magnitude slower than the iPhone in your pocket, and they could do 20-day simulations, atmosphere only, for winter, summer, and spring. And this is a summer simulation. They put the smoke in at these points. This is what Steve said. This is what the Earth would look like if the Army Corps of Engineers got a hold of it. And so this is a cross section. The smoke after 5 days would be heated and start to be lofted, and after 20 days, it would go into the southern hemisphere, just like the Russians had found. And if you look at the surface temperature, this is the temperature change on day 20. Anything blue is below freezing. So certainly over the land, there would be temperatures below freezing. And so we had a session at the fall AGU meeting a year ago, and this is us, old guys now. Rich Turco, Brian Toon, Tom Ackerman, me, and Gira Stenchikov. So if you want to see what we look like now. So now there are about 13,000 nuclear weapons on the planet. The graph I showed you before was just ones that are deployed. On the top is Russia, the bottom is the US. All the white ones are ones that are been decommissioned. They're sitting on a shelf. They haven't actually been taken apart, but they're sitting on a shelf. They aren't deployed. And this wedge here is the other 7 countries. So let me blow this up so you can see what it looks like. The US and Russia each have about 6,000 weapons, and all the other countries have a couple hundred. Why? So if you claim that you have your weapons for deterrence, how many would you have to put on the capital of your enemy to deter them from attacking you? So when I ask, most people say the answer is 1. So maybe you need 2 if the first one doesn't work. So a couple hundred is more than enough. So why do the US and Russia have thousands still? France, China, and UK could build as many as they want. In fact, there's dozens of countries that could build, that have chosen to build 0, even though they could build them. What can we learn from them? So this is a picture taken from the space station. Can somebody tell me where this is? I'll give you a hint. This orange line is a border between 2 countries. Is anybody typing in the chat? Or do you want to just unmute yourself?
They're guessing between India and Pakistan.
Excellent guess. That's correct. This is India, Pakistan, and Afghanistan in the distance. And these lights are cities. These are huge cities of millions of people, even cities you've never heard about, like Faisalabad. And so if there was a war between India and Pakistan, these cities burn, they would produce lots of smoke. So we asked the question, what if India and Pakistan had a nuclear war? Imagine a skirmish in Kashmir escalating because of poor communication, misunderstanding, panic, and fear. And there's still things going on all the time along this border, and also along this line of actual control. Now there's things going on between China and India. So you can read this all the time. In the New York Times, 2019, there was a skirmish. 40 people were killed. What about this? The U.S. was so proud that we killed Osama bin Laden, but if you were air defense of Pakistan, you saw these invaders coming in. Who would you think invaded? Even the stealth stuff doesn't always work perfectly. Did the U.S. actually risk the possibility of a Pakistan-India war because of this? It didn't happen, fortunately. But so there's many ways that this could start. So we did this 15 years ago. We said, what would happen if India and Pakistan each used 15 kiloton Hiroshima-sized weapons? their arsenals at the time that was about half of each of their arsenals. So it would be horrific. 20 million people would die immediately, and we estimate about 5 million tons of smoke would be injected into the upper atmosphere, accounting for the fuel load, emission factors, and rainout. And we used the state-of-the-art at the time GISS Model E general circulation model, 4x5 degree horizontal resolution, but it had 23 vertical layers going up to 80 kilometers, and it had a code for doing aerosols, which was meant for tropospheric aerosols. We just put soot in the upper atmosphere to see what would happen. And this is a movie I made of where the smoke would be. And on the left is the vertical distribution, globally averaged, and the black line is the tropopause. And so it would be heated by the sun, lofted up into the upper stratosphere, and it turns out it would last for years. The E-folding lifetime would be about 7 years, not 1 year for sulfate aerosols from volcanoes, or not a few months or a few weeks from tropospheric aerosols. And then we calculated what the climate response would be, globally averaged, and this is the blue is the global warming we all know and love, and red is instant climate change you would get from this. It wouldn't be below freezing, but it would be global climate change unprecedented in recorded human history, colder than the Little Ice Age, and last for years. Now, no GCM is perfect, and so two other groups did the simulation, the Sokol model in Switzerland and the Wacom model at NCAR, and they got basically the same answer. And so Mike Mills had nicer graphics at NCAR, so this is his plot of what would happen from the Wacom model. And so the dates across the top here, this is April going into the Northern Hemisphere summer, so the smoke is heated in the Northern Hemisphere and goes up to the top here, and then as it gets to Southern Hemisphere summer, it moves to the Southern Hemisphere. And this is a logarithmic scale, these shading, and so there's virtually none going into the troposphere. This would last for many years. Now, in my model, I guess, again, we got heating of the stratosphere, and this would destroy ozone. And so it's from a paper that the group... Oh, no, sorry. Sorry, I always turn my phone off in my teaching, but I forgot about it. This is done at NCAR, and this is the normal ozone, the latitudinal distribution. And in October, it goes below 220 Dobson units, and that's the ozone hole. But ozone would be destroyed, and would basically have a global nuclear winter ozone hole. And severe ozone loss and enhanced UV would have impacts on our health, on skin cancer, on plants. Nobody's actually studied the plants, crops, and ecosystems. We're trying to do that now, and on fisheries. So this remains to be studied what the effects would be. But it's actually worse than that. This is a Trident submarine. It has about 96 nuclear weapons. And nuclear weapons that the US deploys now are 100 or 500 kilotons. So one of these is 1,000 Hiroshimas, not 100 Hiroshimas I've been talking about so far. And we have 14 of them. And that's half of our arsenal. And Russia's got the same. So we really have like 50,000 Hiroshimas, not 100 Hiroshimas. And so now that we have a climate model that can have the whole atmosphere and the ocean too, we decided to go back and see was nuclear winter actually correct. We did a simulation with the GISS model of 50 or 150 million tons of smoke, not 5. And this is a movie of where the smoke would go. It's much darker and would cover the world. And when we plot the surface temperature a year later, this is June, July, August, Northern Hemisphere summer. This is the temperature change, 20, 30 degrees colder. So let's take a place in the Ukraine where they grow grain in Russia. And this is a time series of the daily minimum temperature from one of the ensemble members. The black is the control, so it gets up to 20, 25, 70 degrees Fahrenheit in the summer, gets below freezing in winter. But once you put the smoke in, temperatures go below freezing and stay below freezing for a couple of years. So really, there would be nuclear winter. For different amounts of smoke, you get different temperature responses. It's nonlinear because once you put a certain amount of smoke in, every additional smoke molecule has less sunlight to absorb. So this is temperature on the left and precipitation on the right, 5, 50, 150 teragrams of smoke. So 150 teragrams, temperatures would get 5 or 6, 7 or 8 degrees colder than normal for years. And remember, the global average temperature during the last ice age 20,000 years ago was about 5 degrees colder than normal. If you plot it on the global warming curve, you've got to rescale it. If you plot it on the hockey stick diagram for the last 1,000 years, this is what would happen. Now, we've done more simulations recently with Wacom, the model at NCAR on 2-degree resolution, 66 vertical layers with more sophisticated ozone and aerosols. And we've done a number of different simulations with different amounts of smoke because India now and Pakistan have bigger weapons, more of them, and maybe they could put 20 or 37 teragrams of smoke. And this is the land temperature change. For the 5 teragram case we did before, 2 degrees. And it could get that cold on land just from an India-Pakistan war. And then we said, what would happen to crops? And so we took a bunch of crop models around the world, and from the Global Gridded Crop Model Initiative, and we published a paper last year in PNAS looking at how crops would change. And this is for corn, for maize, for 5 teragrams, and for each place, the yellow and red are a huge reduction in corn production, and the greens are slight increases. In global average, we have a minus 13 degrees, 13% change of corn for 5 years. And for 16 teragrams, a minus 34% change. And it would be similar for wheat and rice and soybeans, the main crops. And so we estimate there would be a huge food shortage, even from a war between India and Pakistan. We've also looked at all the crops now with the NCAR model, and for the 150 teragram case, basically corn production, agriculture would stop. So that's the climate modeling, but of course we can't do the experiment in the real world, and so we look at analogs to see whether they're true, whether inform us. So it's called nuclear winter. So that means that temperatures would be like winter. So we know when you look outside in Madison today, it's pretty cold. You know, if there's less sunlight and the days are shorter, it gets cold. Or, you know, at night it gets cold. So we have a gut feeling for what happens when you turn the sun off. We know that cities can burn. And what about the transport of smoke and dust? So in Mars, there was a, by the way, Matt, when should I stop?
So nominally we can go to 2:15, but I think we have a 5 to 10 minute grace period before the colloquium at 3:30.
Okay, thanks. So we've observed dust storms in Mars. When around Mars, the smoke gets heated and covers the whole planet after a couple weeks. Asteroid impact killed the dinosaurs with lots of smoke. There have been forest fires. This was in Yellowstone. I took this picture in 2007, but the fires were in 1988, and this is a satellite image of the smoke going across the Midwest. This is September 7th, September 8th. And I looked at how the temperature would change in the Midwest, and this is the Moss error of the forecast. And because there was no smoke in the Moss forecast, temperatures would be 4 or 5 degrees colder than normal. Now, pyrocumulonimbus, occasionally there are huge forest fires that actually pump smoke into the stratosphere. And we published a paper in Science 2 years ago now of this huge fire in Western Canada. And what happened was the smoke was injected into the lower stratosphere, and then it rose from 12 to 23 kilometers within 2 months. We observed that with satellites, and we modeled it with the same WACA model we're using for geoengineering. It was only about 0.3 of a teragram of soot, so it gives us faith that when we put in 10 or 100 times more smoke, that the model is actually doing the right thing. And then a year ago in Australia, there was forest fires, horrible forest fires, I'm sure you read about, that produced about 3 times as much smoke. And it was observed that the smoke circled the globe twice, rising from 14 to 35 kilometers over a period of 4 months. And it's still there. So unfortunately, I have these terrible forest fires, but they inform us that these things do happen. From volcanic eruptions, this is the volcanic sunset that monks saw after the Krakatoa eruption over Oslo. El Chichon was one of the most recent big eruptions. This is before and after. And the smoke, I observed the aerosols going around the world in 3 weeks. This is the Tambora that erupted in 1815. Ronald Reagan mentioned it produced the year without a summer in 1816. And that summer, Percy Shelley, Mary Shelley, and Lord Byron were having their vacation on the shores of Lake Geneva, but it was so cold and gloomy and rainy they couldn't go hiking, so they decided to have a contest so you could write the scariest ghost story. And I'm sure you know that that's when Mary Shelley wrote Frankenstein. But Byron wrote a poem called Darkness, which I learned about from some Russian scientists who were working on nuclear winter. It's called, I had a dream, which was not all a dream. The bright sun was extinguished, and the stars had wandered darkly into the eternal space, rayless and pathless, and the icy earth swung blind and blackening the moonless air. And morn came and went and came and brought no day, and men forgot their passions in the dread of this their desolation. All hearts were chilled to a selfish prayer for light. It wasn't really that bad. It was about 1 degree Celsius colder, but this is poetic license. It sounds just like nuclear winter. So what are the conclusions? A nuclear war between any nuclear states using much less than 1% of the current nuclear arsenal will produce climate change unprecedented in human history. Such a so-called small nuclear war would reduce food production by 10 to 40% for a decade, increase UV. Nuclear winter theory is correct. The current arsenal can still produce nuclear winter, producing global famine, and the effects would last for more than a decade. So how do you feel? I took this picture at a concert before they told me to put my camera away. It's kind of depressing, isn't it? As Mark Twain said, denial ain't just a river in Egypt. It would feel better just to pretend you didn't hear this, even though, I don't know, Matt, if it's going to be on the final or not. But but my reaction is to try and do something about it, not just to deny it. So, and that was Sherry Rowland's response too. So what have people done to deal with this problem? There have been treaties to limit the number of nuclear weapons. The Nuclear Non-Proliferation Treaty in 1968 sort of locked in the 5 permanent members of the Security Council, the first 5 countries to have nuclear weapons, but it requires that Article 6, that they be have a treaty on general and complete disarmament, but they've ignored that. There've been other treaties, and but in 2010, Obama and Medvedev signed the New START Treaty, which requires that the U.S. and Russia keep their arsenals at about 1,550 weapons. And it expired this week, but Biden and Putin just extended it for another 5 years. It's the only treaty we still have, the New START Treaty. The U.S. Withdrew from the Intermediate Range Nuclear Forces Agreement, the Open Skies Treaty, so it's the only one that's left. There have been treaties to ban nuclear weapons in certain places, in Antarctica, Latin America, outer space, the seabed, South Pacific, Southeast Asia, Africa, Central America. But in 2017, with my participation, the Treaty on the Prohibition of Nuclear Weapons was signed, and it prohibits nuclear weapons, and it came into force just 2 weeks ago. Here's a map showing where there are nuclear weapons in the world. There's no nuclear weapons in the Southern Hemisphere. There's 1 country in North America, 2 in Europe, and 6 in Asia that have nuclear weapons. So this was done by, so nuclear states claim that their arsenals are not to use, but for deterrence. And we don't want to use them, we just want to deter an attack. But clearly deterrence doesn't work against terrorists or cyber warfare or non-nuclear attacks. For example, the Soviet Union took over Eastern Europe when the US was the only country with nuclear weapons. That didn't deter them. Israel was attacked during the Six-Day War. Their weapons didn't deter them. Argentina attacked the UK on the Malvinas and the Falkland Islands. Their weapons didn't deter them. The Afghanistan war was lost by 2 nuclear nations, and the US didn't win Vietnam. So clearly, deterrence doesn't work. Oh, they'll say, but deterrence works against nuclear nations. Well, there hasn't been an attack of one nuclear nation on another one. That's true. But why? Was it because of deterrence, or was it for other reasons? There have been all kinds of increases in international commerce, increase in the number of democracies, NATO, UN, European Union. We don't know what deterrence role had, but if it's going to work, it has to work forever. There can't be any mistakes. And there have been so many times when we've had nuclear close calls. The worst was during the Cuban Missile Crisis. A U-2 spy plane was shot down over Cuba. A submarine almost launched a nuclear torpedo when it was being depth charged by a U.S. ship. And Vasily Arkhipov was on that Russian submarine with a nuclear torpedo, and he single-handedly prevented them from launching it. In 1999, the India-Pakistan war almost resulted in nuclear war. There was a radar malfunction in Russia, and they thought that they were being attacked, but Stanislav Petrov said, no, I don't think that's what's happening. And so he also is called the man who saved the world. So that we've come very close. Once there was a training tape put in, they woke up William Perry, the defense secretary, in the middle of the night. We have to start a war, and it turns out it was a mistake. So will they last? So how many other incidents were there that were kept secret? How much longer can our luck hold out? So the problem is the treaty was reached. It's now come into force with 50 countries ratifying it. And that came into force on January 22nd, 2 days after Biden was inaugurated. But how do we get the other countries to listen to the will of the rest of the world? So these are the countries that have trying to ignore it. Now, I got invited. The Cuban Missile Crisis was when we came closest. There were 36 nuclear weapons, missiles in Cuba. Each one had the power of 77 Hiroshima weapons. I took this picture at a museum there by the Met Office, the Meteorological Institute in Havana. And I was invited to Cuba to give a talk about nuclear winter by this guy, and he gave me a picture and autographed it afterwards, and then he gave me his autobiography to practice my Spanish. And then he blogged the next week that we have to get rid of nuclear weapons. And Cuba was one of the first countries to sign ratify the Treaty on Prohibition of Nuclear Weapons. But they don't have any nuclear weapons anymore to get rid of. So what can we do? Well, there was they said, can we videotape your lecture? And they showed it in prime time and across the country the next day. And I went into a hotel to see whether I was on TV, and we walked in and there was a Julia Roberts film on. I said, can you change the channel? And sure enough, there I was giving a lecture. And that taught me that a professor giving a lecture isn't nearly as effective as a feature film. Imagine this beautiful scientist in St. Petersburg, and then there's this handsome scientist in Oak Ridge where they're collaborating. Meanwhile, along the Kashmiri border, and there's a little sex and a little violent, and they save the world, but I haven't been able to get that film made. Brian Tuner and I did get an op-ed in the New York Times 5 years ago about nuclear winter, but I haven't been successful since then in getting an op-ed there. The most recent administration has had nuclear arms control in reverse. First of all, George W. Bush took us out of the Anti-Ballistic Missile Treaty, but then Trump took us out of the Iran Agreement, took us out of the Intermediate Range Nuclear Forces Agreement, took us out of Open Skies Treaty. They talked about having a new test of nuclear weapons when the US and Russia haven't tested nuclear weapons for decades, and wouldn't extend the New START Treaty. So there have been Nobel Prizes, peace prizes for people working on this, and the International Campaign to Abolish Nuclear Weapons got the Nobel Peace Prize in 2017 for its work to draw attention to the catastrophic humanitarian consequences of any use of nuclear weapons. That's our work, and for groundbreaking efforts to achieve the treaty. They got this treaty through the United Nations. And when they got when Beatrice Finn accepted the prize for ICANN, she said, if only a small fraction of today's nuclear weapons were used, soot and smoke from the firestorms would loft high in the atmosphere, cooling, darkening, and drying the earth for more than a decade. It would obliterate food crops, putting billions at risk. Yet we continue to live in denial of their existential threat. The story of nuclear weapons will have an ending, and it's up to us what that ending will be. Will it be the end of nuclear weapons, or will it be the end of us? One of these things will happen. The only rational course of action is to cease living under the conditions where our mutual destruction is only one impulsive tantrum away. So nuclear weapons can be used if they exist. A nuclear war could start tomorrow by accident, hackers, computer failure, bad sensors, or unstable leaders. And nuclear arsenals don't deter attacks from non-nuclear states, from terrorists or pandemics. The only way deterrence could work between nuclear states is if states believe other states are willing to kill themselves by using their nuclear weapons. So if we say to Russia, we're going to attack you with our arsenal if you attack us, but if we attack them, even if they didn't do anything, we'd all die from starvation from the climate response. So they have to believe that we would be a suicide bomber. It's just completely irrational. The only way to prevent a global catastrophe is to get rid of the nuclear weapons. So if the US and Russia immediately got down to 200 weapons like the other nuclear states, there wouldn't be nuclear winter. The temperatures wouldn't get below freezing. It would be catastrophic, but it wouldn't kill everybody. But only nuclear abolition would prevent nuclear famine. So what I've done recently last year is join the Physicists Coalition for Nuclear Threat Reduction. It's organized by a bunch of people at Princeton and other places. It's funded by the American Physical Society. They have a full-time staff there. And we go around to physics departments around the country giving a talk and asking them to join us. And we've done like 60 lectures already. I was going to travel, but now we do it by Zoom. And what do? We do advocacy in Congress and with the public. And what have we done? So in 2020, we advocated for two things. Don't resume nuclear testing, because it was in the non-defense nuclear appropriations bill for the Defense Department and in the Senate version, but not the House version. It did get taken out. And we wanted to extend the New START Treaty for 5 more years. And even though Trump was trying to negotiate and never did it, Biden wanted to do it, Putin wanted to do it, and it was done this past week. Great. So we, along with lots of other people, were saying that these things should be done. What's next? We want to eliminate launch on warning. The U.S. has 3 types of nuclear weapons. They have ground-based missiles, they have submarines, and they have airplanes. And ground-based missiles, the Russians know where they are. So if we don't launch them, if they're being attacked, we lose them. So a decision would have to be made within a few minutes. It's a very unstable situation. In fact, we have to eliminate the land-based ICBMs because all they do is make a target. And if we ever want to use nuclear weapons, which I don't know why, but if we ever want to use them, we can always use the ones on the submarines, which are invulnerable. Now, the president has the sole authority to launch nuclear weapons. It's an artifact of what happened after World War II, when Truman said, I don't want to trust the military with that decision, but why don't we have a committee? Why don't we think about it for a while? There's no reason to have to use them instantaneously. And we should also adopt a no first use policy, that we should not use them before. And so we're trying to advocate for these things now. So Carl Sagan, the famous astronomer and collaborator on some of the first works, was asked, do you really want to get rid of nuclear weapons? And he said, for myself, I would far rather have a world in which the climatic catastrophe cannot happen, independent of the vicissitudes of leaders, institutions, and machines. This seems to me elementary planetary hygiene as well as elementary patriotism. And I think I agree. Elementary planetary hygiene demands we eliminate nuclear weapons faster than the current pace. So unless someone like you cares a whole awful lot, nothing is going to get better. It's not. So I hope we learn from this, and our beautiful planet ends up looking like this for much longer, for a long time. So, and if you want more information, copy of the PowerPoint. Here's my website. Thanks.
Well, let's thank Alan with our emojis. And if you want to turn on your microphone and ask questions, or if you'd like to ask questions through a chat window, please do. Thank you so much. That was a really great talk.
I have a question.
Yes.
There's been lots of talk about EMP weapons, and they could be possibly used without causing this climatic catastrophe, just destroying nations and their infrastructure. Is that something that countries might go toward? as opposed to nuclear weapons and ground blasts?
So EMP is an electromagnetic pulse, and if you blow up a nuclear weapon high in the atmosphere or above the atmosphere, it would send a blast of radio waves that would destroy a lot of electronics. I don't know anything about it, so I know what it is. And once a Russian defected with a Russian fighter plane, and when he landed, they opened up the plane, and there were all vacuum tubes in the electronics. They said, "Oh, these Russians are really backwards," but actually, vacuum tubes are not subject to EMP. So they figured that and now all the electronics are hardened, I think, in the military. So yes, it would be a disaster. It would be easy for any country to do that, and so I've never heard of people saying we're going to deter you because we might want to use EMP, because of course the other country could use it too with a few weapons, and that would be it. So I don't know. I'm not an expert on that, so I don't know. But it wouldn't cause climate change unless all the tractors and all the grocery stores had no more electricity, and so you couldn't distribute the food or harvest it or distribute it. So indirectly, it could cause famine.
Any of the 405 students have a comment or question?
How did you get into this research, Dr. Robock?
Well, I mentioned I've always worked on volcanoes and climate, and so I was intrigued by that one talk at the AGU meeting on climatic effects of nuclear war, and so I went to it, and it was canceled, but then I found out what they were working on, and so I said, I can do this with my climate model. I can put soot in instead of sulfate aerosols and see what the climate response would be. And I attended the first conference between the U.S. and Russia. It was at the Sheraton, at the Shoreham Hotel in Washington, D.C. I was at the University of Maryland then, so it was just downtown. And they had a satellite link, and there were Russian and Americans both presenting their results at the same time. And then I saw that Gorbachev and Reagan listened to the scientists, and it changed policy. And I said, wow, that's really interesting. And we can actually have an effect. So I started working on it, and I didn't have any funding, and so but I couldn't not do it. It was just such an interesting problem. You know, when I was in Madison, it was during the Vietnam War, and they wanted me. I had to sign up for the draft, and when I graduated, they wanted me to go to Vietnam and kill people, and I thought that was a terrible idea. And so I was participating in protests in Madison. I got tear gassed 3 out of the 4 years I was there. I lived in the 500 block of Mifflin Street. I was there for the first Mifflin Street block party, and we stopped the war in Vietnam. We ended it. So I was sort of, I learned some meteorology while I was in Madison too, but I also learned how people could affect policy. And so I sort of got the bug then, I suppose. And Matt didn't mention instead of going to Vietnam, I joined the Peace Corps for 2 years, and I was in the Philippines, and I taught teachers how to teach meteorology in the fishery schools before I went to graduate school. So that was, if you read the paper he sent out, which is my perspectives paper, it tells how I made decisions like that. And it was 15 years ago that I ran into Brian Toon and Rich Turco at the AGU meeting, and they said, somebody asked us what would happen if India and Pakistan had a nuclear war. I said, not much, but then we calculated maybe 5 or 6 teragrams of smoke, and I said, who's going to calculate the climate response? They said, well, we thought maybe you would. And my student Luke Oman was studying volcanoes and climate with a climate model. We just put smoke in and saw what would happen. And Yuri Stenchikov had come to the United States to work with me, and he was a research scientist with me, and so we did it together. Now he's a professor at KAUST in Saudi Arabia, so we worked together for a long time on that too. So nuclear winter's been good to me.
I have a question.
Sure.
Just considering your background, have you ever visited the Los Alamos laboratory in New Mexico? Colleen, who's a classmate and friend of mine, her aunt works there. I'm just wondering if you've ever been down there.
I did visit there once. There was a conference there on the effects of solar variations on climate. So the meeting was held not in the lab, but in the town right next to it. It's a spooky place. One summer, though, when I was a graduate student, I spent the summer working at Lawrence Livermore National Lab, which is one of the other nuclear labs, and I did research on air pollution. But I'd have top secret security clearance to work there, although I didn't do anything that was secret.
Very cool. Yeah, I
But
was
I've been
down
to
there. Oh, sorry, go ahead.
I've been to Hiroshima and Nagasaki, and those
Wow.
are the places that are worth visiting.
I didn't even know that Los Alamos existed until I got pulled over on their property. I didn't know that I was on their property, but I was on the wrong side of the road, I guess. On the other side of the road, it's like the Bandelier National Monument, which is, you know, a public park. But I pulled over on the laboratory side of the road, and it's just like woods and stuff because I wanted to take a picture of the mountains. And a guy came up behind me like instantly. He was like, "You have to leave because this is restricted property or whatever." So that was interesting. But yeah.
If I could ask a question, I was really struck by how warm the stratosphere gets with that soot loading, and I was kind of hoping that it might help offset some of the limitation of the solar downwelling beam by having more downwelling infrared to the surface, but I'm sure your model takes account of that, and so. But that's spectacular warming in the stratosphere.
Yes, some of the so it's 80 degrees warmer than what, -50, so it doesn't get that warm compared to surface temperatures. But yes, it would be, there's not much air there, so you don't need that much energy to warm it up, and so but it would depend on the emissivity of the particles too, and of the air. But no, the model takes that into consideration. So in spite of the downward long wave, you still get cooling at the surface. And the UV, for the 150 teragram case, there's so much smoke that not much UV will get to the surface, even though you destroyed the ozone. So it's not till a few years later that you start getting an effect of UV on the surface, if there's anything left alive.
Is it hard to translate number of bombs to teragrams of soot?
Yes, that's the hardest. That's the hardest problem. If once you put a certain amount of smoke in the atmosphere, the climate response is pretty robust. But how do you? We're using warped fire now to try and do firestorms and burn cities. Nobody's ever done it before. They've used it for burning forest fires. So the question is, what's the fuel loading? So we have a team that goes around, looks at every building in cities, and tries to see how much material is there, and what type of building, how tall are they, what's inside of them. And this was done in the 1980s. They did, the Defense Nuclear Agency paid somebody to take Nashville, Tennessee, and look at every building there and what was in it: schools, homes, factories, libraries, and so forth. We wrote to Google and said, you know, Google Earth has these 3D models of buildings in most cities now. Can we have the information? We don't want to compete with you. We just want to burn them. And we haven't been able to find anybody there to give us the data. So we're sort of doing it from other databases. But yes, we have a team doing that. And then the question is, once it burns, what fraction of the mass ends up as soot? And typically it's like 2 or 3%, but it depends how it burns. And then what's the chemistry of it? Is it black soot, or is it a lot of organics? Is there soot coating the black? Is there organics coating the black soot? So we're working hard on that part too.
I can mention something.
I just wanted to mention, we've had trouble getting funding for this. We asked the Defense Department, who has the bombs, the Energy Department who makes the bombs, Homeland Security, CIA, NSF. Nobody wanted to fund us, but I happened upon the Open Philanthropy Project, which is funded by Facebook billionaire Dustin Moskowitz and his wife Carrie Tuna, and they were able to give us a grant, $1 million a year for the past 4 years now, to fund a big research project on this. If it wasn't for them, we wouldn't have had any of these results. And so we're really thankful to them for funding us. We think that the federal government should fund it, but they haven't.
I have one more question, actually, if that's all right.
Go ahead.
Please do.
In the case of a nuclear winter, I guess there's many different scenarios you could look at. But in general, is there a certain trend that comes up as far as the pole to equator temperature gradient? Like how does that meridional temperature gradient get affected by a nuclear winter? So
we have a paper about that. It was published last year by Josh Coop, C-O-U-P-E. He's my student then. So go look at that. He compared the Wacom simulations with the GIST simulations from 15 years ago, and they both get the same answer, that you get a strong polar positive AO mode, strong polar vortex. We also have a paper which we just published a week ago on nuclear Nino. You get an El Nino that lasts for almost a decade because of the changing circulation in the ocean. And so there's interesting dynamical responses in the atmosphere and the ocean, which can then affect fish in the sea, for example. So go to my homepage and click on publications, on latest publications, or click on nuclear winter publications, and the papers are there.
Sounds good. Thank you.
Can I mention something? Back in the 80s, when I was working on this, we did some modeling of the pyrocumulus that would exist, including breaking down cities. We did San Jose and a couple others. But one of the things we found is that the storms would have such tremendous upward velocity in these pyrocumulus that the nucleation process would suppress scavenging, in the sense that what would happen is all these semi-organic aerosols, which would not be pure elemental carbon, but have some compounds, like I think you were saying, they would nucleate to form cloud droplets, but then those cloud droplets would essentially never be rhymed because of the tremendous updraft velocities, and they get thrown straight out into the stratosphere, and they re-evaporate. And you put essentially almost 100% of the smoke up into the stratosphere.
Wow.
The nucleation would be almost totally ineffective.
Can you send me a link to your papers on that?
No, I didn't write a paper. It's in that book anywhere. The environmental causes of nuclear.
Okay. Yeah. That's great. There was black rain in Hiroshima, so some of the smoke was rained out, but a lot of it. And I wrote a paper on did the smoke from all those 60-some fires in Japan that summer cause climate change, and I published it in JGR a couple years ago with Brian Zambry, and you can look at it. It turns out the data aren't very good. We don't have good data on what the emissions were. We don't have good data on temperatures because, as you know, during World War II, the ships were in different places, and so they were also switching from bucket to intake temperatures, and so we looked at land temperatures, and it turns out, and there's only 2 observatories measuring the amount of sunlight, but they had to account for cirrus clouds. So the data aren't very good, but it turns out that the global temperatures went down by a couple tenths of a degree, which coincides with what you would expect, but natural variability is so large that it's not a significant signal. So there wasn't probably enough smoke from those fires, but that's the only analog that we have to look at that.
Is there another quick question, or?
Thanks, Greg. I'll go back and look at that. The book's on my shelf in my office. I'll have to go there one of these years and get it.
That was a fantastic session. Thank you so much. That was really interesting. You're right, it is somewhat depressing, but it's very fascinating, very, very important.
Welcome.
So, thank you.
Well, I saw, this is my Bucky Badger. I saw that Wisconsin's going to play football at Rutgers in November this year if the football season starts again. And I'm planning to go and root for the Badgers.
All right.
If you go in person.
Yeah, in person. Wouldn't that be fun?
Yeah, how bizarre.
My pleasure. Thanks for inviting me.
Yeah,
thank you very much, Professor Robock.
You can sign off too, Alan, if you want to do something. I just got a message from Adrian Tuck, and he's writing about the cure in a balloon test with no instruments on board, just to kind of prep work for doing a small test of geoengineering. In Sweden, some groups are a little bit concerned about the longer term implications of doing such. And I was wondering if you had an opinion about that.
Yeah, that's the ScopeX experiment from the group at Harvard. They want to fly a balloon up and spray a couple kilograms of stuff to see what would be the impact on ozone. And this experiment is just to test the balloon without it spraying anything. And by the way, you're still recording in case you want to stop it at
Oh,
some point.
okay. Yeah, I'll stop it. Sorry.
And